So my space is starting to run out on my board, so I'm writing smaller and smaller and smaller. Hope you can read it. So today we're going to find out what we're going to do about two terms, but just to make sure you're ready for your quiz tomorrow, because it's got the whole thing on it. Factoring 101, one last time, you got to take out the GCF. Then you got to make sure you count your terms. If you end up with 4 terms, then you are going to try grouping where you take a GCF out of the first 2 terms, you take a GCF out of the last 2 terms, then you take out the common GCF. If it has 3 terms, then you have to ask yourself, what is the leading coefficient? If the leading coefficient is 1, that means you follow the rules. Rule number 1, draw your skeleton. Rule number 2, 2 things multiply together to give you first term. Rule number 3, multiply to give you the last term, and add or subtract to give you the middle term. Rule number 4, plus in the back means the signs are the same as the sign in the front. Rule number 5, minus in the back means the signs are different, and the larger number gets the sign in the front. And rule number 6, you should check it. If you end up with a leading coefficient that is not 1, that's a 1 with a line through it, like don't walk here kind of thing, no entry kind of, anyway, not 1, then you have to follow trial and error. Step number 1, draw the skeleton. Step number 2, 2 things multiply together give you first term. Step number 3, 2 things multiply together give you last term. Step number 4, plus sign in the back means the signs are the same as whatever the sign in the front was. Minus sign in the back, this is number 5, means the signs are different, because that's all you can tell from that. And you have to make sure you check it. Always check it to make sure that it's right. Then for 2 terms, sorry, a little out of breath. 2 terms, you need to look to see if it is a difference of 2 squares. If it is a difference of 2 squares, then you can do the following. 1, take square root of the first, put it in both places. 2, take the square root of the last. Put it in both places. And then 3, one's plus and one's minus. Always. Now, when you get into Algebra 2, and it's coming, there'll be 2 other things that you can do there other than just the difference of 2 squares, but right now we're just leaving it at the difference of 2 squares. Which isn't like me, because normally if we got something in Algebra 2, I'd go ahead and throw that on you too. That's just the way I am. I want you to go ahead and get all the hard stuff out of the way. But we're going to wait on it because there ain't nothing in the book about it yet, and there's no need to rush you anymore. You're already rushed. I know you're tired as it is. You got to be, because I'm exhausted. It's an exhausting section to me. So we have all of this. On Friday, when you take your quiz, you will have to write this. I know you said something about you wanting to practice writing it, and that's fine, good, and wonderful. Don't practice writing it like this, though. Practice writing it out with your words, not necessarily my words, so that when I read it, I go, okay, that's really what you do. Okay, that's really what you do. Okay, that's really what you do. Because if you write something like, you know, 2 things that multiply, if that's all you tell me, I'm going to be a hot somebody because you didn't tell me to multiply to what? You understand what I'm saying? But it doesn't have to say two things that multiply. You could say, look at the first term. You need two things that multiply together to give you the first term. Or you could say they multiply together to give you the last term. Or they add and subtract to give you the middle. I need it in your words, not necessarily my words. Same thing with this over here. This got really short really quick because we were writing it over and over again. I need to know what it all is, not just kind of what it looks like. Okay, so have fun with that. And we're back. Pretty sure we're back. Okay. So I had to give me some space for us practicing the two terms so I could demonstrate it a little bit. I was creatively looking at page 290 in your book. Before we get to that, you have to be able to recognize whether or not it's the difference of two squares, which means they both have to be perfect squares. So I wanted to list off some perfect squares for you. For example, 4 is a perfect square because it's 2 times 2. 9 is a perfect square because it's 3 times 3. 16, 25, 36, I bet you know these. 49, 64, 81, 100, 121, 144, 169, 196, 225, 256. Nobody cares about 17, 18, or 19. 400 is a perfect square because it's 20 times 20. 625 is a perfect square because it's 25 times 25. And 900 is a perfect square because it's 30 times 30. But something you don't think about being a perfect square would be like x squared. That's a perfect square because it's x times x. What about x to the 4th? That's a perfect square because it's x squared times x squared. What about x to the 6th? That's a perfect square because it's x to the 3rd times x to the 3rd. So forth and so on. And just like you can do it with x's, you can do it with y's and with anything else. So let's look at a problem. A squared minus 121. Wish I knew what problem it was. Might have just made it up. I do that sometimes. It's got an A in it, so I doubt I did. But I ain't finding it now. Oh, number 26. So there is no GCF. It has two terms. Push me over there. Let's see if it's a difference of two squares. That's a perfect square. That's a perfect square. There's a minus. That's what that difference part's talking about. Since there's a minus and they're both perfect squares, yes, it is the difference of two squares. So that means I'm going to have two sets of parentheses, just like always. And two things that multiply together give me the first one, so I take the square root of this. Basically, that's A and A. And then I take the square root of the last one. So we already said that was 11 and 11. And then one is plus and one is minus. You don't even need to multiply it out to check it. Your only issue would be if you got the 11 part right, because everything else you know is right. I'm perfect. Well, I know it's right. Okay, you really wanted me to multiply it. I can multiply it out if you want me to multiply it out. It's not that I can't do it. It's that I didn't see a need for it. But if you need me to, here, I'll do it. So a times a is a squared. A times negative 11 is negative 11a. 11 times a is positive 11a. And 11 times 11 is negative 121. If you'll notice, the middle two terms will cancel each other out every single time. That's why we had to look for a difference of two squares. That's what's happened. The middle two terms have canceled each other out. And that's why you end up with the a squared minus the 121. See, it's right. But why you couldn't just believe me before? It's okay. It's okay. I still love you. A little bit. Let's try another one. 16z squared minus 49. Is there a GCF? No. Count the number of terms. 1, 2 terms puts me over there. Is this the difference of two squares? Well, this is a perfect square, 16, because it was on our list. Z squared is a perfect square, so that's a perfect square. That's a perfect square, and that's a minus, so yes, it is the difference of two squares. Take the square root of the first one. That's 4z and 4z. Square root of the last one, that's 7 and 7. One's always a plus, one's always a minus. So it don't matter which one's which. You know that. All right. A few more. Then I'm going to be done. It's going to be all up to you. Oh, I got a lot of these up here. Okay, fine. 81z squared minus 16z. Step 1. Take out the GCF. Do we have a GCF? Of course we have a GCF. It's z. So I'm going to take out the z. That leaves me with 81z minus 16. Two terms. Is it the difference of two squares? Well, the 81 is a perfect square, but the z is not a perfect square. So no, it can't be the difference of two squares, which means we're done. You cannot say that something is prime if you have done anything on this chart. It has to be completely not done anything. If you take out a GCF, it is no longer prime. So you can't have done anything on this chart in order for it to be prime. So that makes our answer that. Next, 144m squared minus 81. Step 1, take out a GCF. Is there a GCF? Why, yes, there is. 9 goes into both. 9 goes into this 16 times. 9 goes into 81 9 times. Now, I know back up here, you were thinking, oh, that's the difference of two squares. Let me just go ahead and do it like that. And I'm telling you, that's going to mess you up. You've got to make sure you always take out your GCF. If it was the difference of two squares here and you take out your GCF, it should still be the difference of two squares down here. See, this one is. It might be different squares, but it's going to be the difference of two squares. So now I have a 9 on the outside and 4m and 3. 1 plus, 1 minus. It don't matter which one's which. Got 3 more on this list. You want to try one? I know you do. It's all right. 121 m to the 6 n squared minus 81. Go ahead and try this one. Pause it. Let's see what you do. Okay. So for this one, is this a perfect square? Why, yes, this is, yes, that is, and yes, that is, and that is too. And it is a difference, so it works. Is there a GCF? No. No, because that's 11, and 11 don't go into that. Count number of terms, 2 terms. See, I did all that stuff in my head. So, square root of this is 11. Square root of that is n to the 3rd. Square root of that is n. Square root of that is 9. One of them's plus, one of them's minus. Hope you got it right. Sorry if you didn't. I have another one for you to try. 25a squared plus 20a plus 4. Wait a minute. What's this one doing in this section? It ain't got 2 terms. It's got 3 terms. This is back another section. Why is it here? Well, if you were to do the 3 terms, is there a GCF? No. What's your leading coefficient? Not a 1. So 2 days multiplied together give you that. Gut says 5a, 5a. 2 days multiplied together give you that. 2 and 2, plus and plus. That's what the answer is. Why is it in this section? Because this can be written a special way. Since they are exactly the same, it can be written 5a plus 2 squared, because there are 2 of them. I'm okay with this. I'm okay with that. Your book is okay with either, but it's in this section because it's considered a special case. Sometimes you can look at this and you can say, oh, that's going to end up being the same thing, or a perfect square trinomial. But you can't always look at it and just have that pop into your head. And it's okay if it doesn't, because it's going to come out that way anyway, and you'll be fine. But in this section, that must be what it is. Let's go and put it in here. 16n squared minus 56n plus 49. You notice in a perfect square trinomial, that's what this is, that this has a perfect square and that is a perfect square. Did you notice that? Yep. That's right. So that's going to be 4n and 4n, and that's going to be 7 and 7. And in a perfect square trinomial, you have to follow the rule about a plus in the back. Side's going to be the same as whatever's in the front. So it's going to be a minus and a minus. You can write it either way. You can write it that way, or you can write it that way. Now, I know you're excited. I would be tickled pink if I knew what I know now, and I were you. But it's okay. You don't have to be tickled pink yet. Tickled blue is good enough for me. Classwork for today. Page 290. Numbers 7, 9, 25, 27, 41. Homework. Page 290. Numbers 11, 13, and 29 through 39 odd. Make sure you come talk to me after this to do your classwork. We'll do your classwork together. And then there'll be one other section where we'll have to do classwork together, and that'll be the next section you do, which is going to be 7-9. So tomorrow you're going to take your quiz, and then the next section you're going to do is 7-9. I know we're skipping 7-8 on purpose. Then we'll come back and do 7-8 on Tuesday. Then you'll review on Thursday and test next Friday. So you got a quiz this Friday and a test next Friday. That's pretty serious. But you'll be all right with it. I will see you later. Well, actually, in just a few. Bye.